of the work for this problem is started on the board already. Our boundary curve is going to be what we get if we replace the inequality with an equal sign. So this is just a transformation of the square root graph. We're adding 1 to x before we take the square root. So that's a horizontal change. That's going to shift things to the left 1. And because this is a strict inequality, our boundary curve will be a dotted curve. Now here I've just graphed y equals the square root of x to remind us of the general shape of that. My boundary curve is going to be this curve shifted 1 to the left. So we're going to start at the point -1, 0. This point 1, 1 will shift and actually become a y-intercept 0, 1. And then I'm going to draw that same shape, but as a dotted curve. Okay. So you'll notice the graph is defined if x is -1 or bigger. That's what makes the quantity under that radical defined. So over here to the left of -1, there's no graph. And if there's no graph, there's no above the graph and there's no below the graph. Okay. So let's see. I wanted y less than the y value on the curve, so I want to shade below. I want to be very careful here. There is a point here, so I can shade below it. That line, x equals -1, actually becomes part of my boundary because I can't go any further to the left. Let's just take a look. If I picked a point over here, like let's say I picked -2, -1, okay, I can't evaluate this inequality because y would be -1. Plugging in -2 for x, I would get the square root of -1. Now I'm working in the real numbers here for 2 reasons. One, I'm graphing. And when we're graphing, this is a real axis. X is a real number. This is a real axis. Y is a real number. Second, when I work with complex numbers, and sometimes it's useful to do that, inequalities don't make sense anymore. Real numbers, I can talk about inequalities because they fit on a number line, and smaller numbers are to the left and bigger numbers are to the right. I never really talked about how I would plot the complex numbers, but it turns out one really can't work with inequalities when working with the complex numbers. So when we're graphing, we're working in the real numbers, so it doesn't make sense to plug in a point like this to get a true-false statement, because what we get is nonsense. Not a true statement, not a false statement, something that doesn't make sense if, for this problem, we are working in the real numbers. And anytime we are graphing, anytime we are working with inequalities, it is in the real numbers. So there's nothing over here. The stuff that makes the inequality true is stuff where over here, the x value can legitimately be plugged into that as a real valued function of whose domain is real numbers. Okay. Not all real numbers bigger than or equal to -1.